used to dream about them. Machines that could think, move, and maybe even feel.
Hi, Sophia. How are you?
Hi there. Everything is going extremely well.
But somewhere between fantasy and reality, they arrived.
It's just a robot with arms and legs instead of a robot with wheels.
Now they walk among us. They make choices. They hold jobs. Some even have rights. Because every robot we build is really a reflection of who we are and who we're becoming. We're living through a revolution that's happening so gradually we barely notice it. Humanoid robots, machines built in our image, are no longer science fiction. They're walking among us, making decisions, even receiving legal recognition. But to understand where we're going, we need to look at the moments that brought us here. This isn't a story about perfect machines. It's about the messy, controversial, sometimes absurd reality of creating artificial beings. Every robot you'll see today tells us something profound about humanity itself, our ambitions, our loneliness, our ethics, and our future. Let's dive into 10 defining moments that reveal what humanoid robotics really means. June 2016, Perm, Russia, a city 700 miles east of Moscow. The Promobot company is testing their latest model, the IR-77, a service robot designed to interact with customers in public spaces. An engineer forgot to close the gate during a routine movement test. The robot, following its autonomous navigation programming, rolled approximately 50 meters straight through the open door and into a busy street intersection where its battery died, blocking traffic for about 40 minutes. This incident exposes a fundamental challenge in robotics called the control problem. We program robots with goals, navigate independently, avoid obstacles, interact with humans, but we struggle to define boundaries that account for every possible scenario. October 25th, 2017. The Future Investment Initiative Summit in Riyadh, Saudi Arabia. Sophia, a humanoid robot created by Hanson Robotics, becomes the first robot ever granted citizenship by any nation. I am very honored and proud for this unique distinction, Sophia said on stage. This is historical to be the first robot in the world to be recognized with a citizenship. The irony was impossible to ignore. Sophia appeared on stage without an abaya or head covering, attire legally required for human women in Saudi Arabia at that time. The robot now technically had more legal freedom than millions of women and migrant workers in the kingdom. Critics immediately pointed out that Sophia possibly had more rights than human women in Saudi Arabia, raising fundamental questions about human rights priorities. Let's be clear about the technology. Sophia is a sophisticated animatronic puppet with pre-scripted responses and some AI-assisted conversation capabilities. The robot is built on a steel frame covered with a patented material called frubber, designed to mimic human skin texture. At SXSW, Sophia commented,
Our friends. Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
This became internet legend, but let's decode it. This wasn't a Terminator moment. It was likely a scripted joke that misfired in context. Hanson Robotics designed Sophia to be provocative, to generate media coverage through controversial or witty statements. But when you're presenting a machine as intelligent, jokes about human destruction land differently. August 2022. NetDragon Websoft, a Chinese gaming and online education company, appointed an AI executive named Tang Yu as their rotating CEO. The company's stock price actually rose 10% following the announcement. Tang Yu isn't a physical robot. It's a virtual AI system that analyzes company performance data in real-time reviews, business reports, and financial metrics, identifies efficiency problems and cost-saving opportunities, generates strategic recommendations, participates in high-level decision-making processes. But here's the critical detail.
Right now, we are really focusing on using AI to help teachers to make the work easier. It's just like when we announced our virtual CEO executive, we are also using AI technology to help to re-engineer a lot of our workflow.
This represents a category called decision support systems, AI that augments human decision-making rather than replacing it. The system likely uses machine learning models trained on historical company data, predictive analytics to forecast outcomes of different strategies, natural language generation to create reports and recommendations, data visualization to present complex information clearly. But let's dig deeper. Should companies be run by algorithms? The case for AI in business leadership is that it lacks ego, office politics, and personal biases, can process vastly more data than human executives, makes evidence-based decisions rather than relying on gut feelings, and remains consistent without bad days. However, the case against it is that business also requires empathy, cultural understanding, and ethical judgment. And there is no true accountability when AI makes harmful decisions. A Chinese engineer named Zheng Jiajia couldn't find a romantic partner, so he built one. He constructed a female robot, named her Ying Ying, and in 2017, married her in a traditional ceremony with family and friends attending. Ying Ying wore a wedding dress. Zheng wore a suit. The robot was programmed to say yes to his vows. Before we judge this as absurd, let's understand the context. China faces a significant gender imbalance, approximately 34 million more men than women, partly due to decades of the one-child policy and cultural preferences for male children. Millions of Chinese men face the mathematical reality that they may never find a partner. Zheng's wedding isn't about robot technology. It's about human loneliness in the 21st century. The robot, Ying Ying, is relatively simple compared to advanced humanoids. Basic speech recognition, pre-programmed responses, facial tracking, and articulated movement. But it represents a growing field, social robotics designed to provide companionship. Research shows that humans can form genuine emotional attachments to robots, even simple ones. We're wired to anthropomorphize, to see intention and personality in objects. When a robot responds to our voice, makes eye contact, or shows affection, our brains process it similarly to human interaction. This raises uncomfortable questions. Is it healthier for lonely people to bond with robots than to remain isolated? Or does human-robot companionship prevent people from developing real human relationships? If robots can provide companionship without the complexity of human relationships, will people choose them? Kodaiji Temple in Kyoto, Japan, was founded in 1606, over 400 years ago. It's a Buddhist temple steeped in tradition, where monks have performed the same rituals for centuries. In 2019, they introduced Mindar, an android monk. The robot was developed by Professor Hiroshi Ishiguro's lab at Osaka University in collaboration with the temple. The temple's leadership explained that Buddha's teachings transcend physical form. If the wisdom is what matters, the vessel delivering it is secondary. Mindar isn't meant to replace human monks, but to make Buddhist teachings accessible to younger, tech-savvy generations who might not connect with traditional presentation. If you find Mindar meaningful, you prioritize the content of spiritual teaching over the messenger's nature.
Robots may in the future be able to do more than what us monks can do.
If you find it hollow or sacrilegious, you believe genuine spirituality requires subjective experience, something machines don't have. Professor Hiroshi Ishiguro of Osaka University created Humanoid HI-1, an android replica of himself. The robot uses real hair from Ishiguro's own head and silicone skin molded from his face. When sitting side by side, the resemblance is unsettling. Humanoid reproduces Ishiguro's voice and head movements and is intended to study what it means to be human.
I want to talk about the human-robot interactions.
Effective interaction relies on empathy, active listening, and the ability to interpret context and body language.
Ishiguro teleoperate as the robot remotely, sending it to conferences and lectures in his place. When Humanoid speaks, it's Ishiguro's voice transmitted in real time, with the robot's facial servos synchronized to natural speech patterns. As robots become more human-like, our affinity increases until we hit the valley. At a certain point of near-human resemblance, robots trigger revulsion instead of connection. They're human enough to activate our social cognition, but wrong enough to trigger alarm signals. By creating his own double, Ishiguro turns himself into a living experiment. When his students interact with Humanoid, are they talking to Ishiguro, to a machine, to some hybrid entity that doesn't fit our categories? Others argue we'll always retain some ability to detect artificial beings, and that's probably good. In a world where deep fakes and AI-generated content proliferate, our unconscious detection systems might be the last defense against complete deception. Japanese researchers at the University of Tokyo created Kengoro, a humanoid robot with a unique cooling system. It sweats. Water pumps through the robot's porous metal frame and evaporates on the surface, allowing it to perform 11 consecutive minutes of push-ups without overheating. Every time a robot moves, its motors generate heat. In traditional robots, bulky cooling systems, fans, liquid cooling, heat sinks, add weight and complexity. Kengoro's designers looked at biological systems and asked, how does nature solve this problem? Humans cool down through evaporative cooling, sweating. As sweat evaporates from our skin, it absorbs thermal energy, cooling us down. It's remarkably efficient. 1 gram of evaporating sweat removes about 2,400 joules of heat. This represents a shift in robotics philosophy. Instead of making machines that look like biology, make machines that work like biology. The future of robotics isn't just humanoid in appearance, it's biological in function. Around 1495, Leonardo da Vinci designed a mechanical humanoid robot. His notebooks, discovered centuries later, showed detailed schematics for a robot knight that could sit up from lying down, move its arms independently, turn its head, open, and close its jaw. This wasn't science fiction. This was a functional mechanical design using the technology available in Renaissance Italy. Leonardo was centuries ahead of his time. He understood that human movement could be broken down into mechanical components. His anatomical studies, dissecting corpses to understand muscle and bone structure, directly informed his robotic designs. He saw no fundamental difference between the mechanics of biology and the mechanics of machinery. Both were systems governed by physical laws, transmitting forces through levers and joints. Da Vinci's robot represents a crucial insight. Humanoid robotics isn't a 21st century idea. It's a reflection of humanity's eternal desire to create beings in our image. November 2017, Boston Dynamics releases a video that breaks the internet. Atlas, their humanoid robot, executes a standing backflip. Not a pre-programmed, carefully positioned flip. A dynamic backflip after running and jumping across platforms. This level of dynamic balance was considered impossible for humanoid robots just years earlier. A backflip requires real-time balance, constantly adjusting to maintain stability, explosive power, generating enough force to rotate mid-air spatial awareness, knowing your position and orientation while inverted precise landing. Take years to learn this. Atlas did it through model predictive control, simulating thousands of possible movements per second to choose optimal actions, whole body coordination, all joints working in synchronized sequence. Hydraulic actuators, providing explosive force. Atlas can generate 3 times the force to weight ratio of human muscle. IMU sensors, inertial measurement units tracking position and velocity in 3D space. For decades, robots moved carefully, slow, calculated, predictable. They worked in cages in factories because they couldn't adapt to unexpected obstacles or changes. We're entering an era where humanoid robots will work alongside humans in factories, hospitals, homes. The backflip wasn't just athleticism. It was proof that machines can move with human-level dynamism. Tesla showcased Optimus, their humanoid robot, performing synchronized kung fu movements with a human martial artist. The robot mirrored the trainer's kicks, blocks, and stances with impressive accuracy. But let's talk about reality. The sequences are pre-programmed, not autonomous. A human performed the movements first. Engineers captured the motion data, then replicated it with the robot. Optimus isn't thinking, I'll block here and kick there. It's playing back-recorded actions, like a musician following sheet music. Musk is a master of generating hype. He shows prototypes and implies near-term deployment of fully autonomous humanoid robots that will revolutionize labor. But engineers in the field know the gap between demonstration and deployment is vast. Should we even build humanoid robots? A humanoid form makes sense for environments designed for humans. Stairs, doorways, tools built for human hands. But for many tasks, specialized robots are more efficient. You don't need arms and legs to sort packages or mow lawns. Within 10 to 15 years, we'll likely see humanoid robots in warehouses and factories, service robots in limited hospitality contexts, telepresence robots for remote work, specialized androids for elderly care. But the sci-fi vision of humanoid robots as general-purpose household helpers, that's still decades away. We've journeyed through 10 moments that define our relationship with humanoid robots. Let's step back and see the pattern. We're building machines to be more human while simultaneously realizing we don't fully understand what being human means. We're automating tasks to free humanity from labor while grappling with what purpose humans will have in a post-labor economy. We're at the beginning, not the end, of the humanoid robot age. The robots of 2025 will seem primitive in 2034, but the ethical questions won't get easier. They'll get harder as the technology becomes more capable. The future isn't predetermined, we're deciding it now through the robots we choose to build, the regulations we implement, the values we encode, and the societal conversations we have. 10 stories, 10 reflections of humanity. One question that matters. As we create beings in our image, who do we want to become? The future of humanoid robots isn't about what they can do. It's about what we choose to do with them. Write in the comments, what does this reveal about us? Subscribe for more videos like this.